So yesterday we looked at multiplying fractions visually. Today what we're going to be doing is looking at algebraically multiplying fractions. We're going to start off with our basic fractions like 2/3 times 3/4. We are then going to be multiplying mixed numbers, and then towards the end we'll be multiplying fractions with variables in the problem. So based on what we learned yesterday, how could we multiply these two fractions? Max?
So, do we do like with the tiles or with like
No, well, if I remember correctly, some people said that we could do a diagonal thing that it didn't end up working out right. So what was the other way? Aubrey?
You just multiply the denominators
And the other ones, good use of vocabulary, yeah, numerators and denominators. So numerator times numerator, denominator times denominator. There's actually a step that we can do before that to simplify the problem before we multiply. Okay? How could I do that?
type it in your calculator?
Okay, so a calculator would definitely help on this, but we don't need it. And when we use the variables in our problems, the calculator is not going to help us at all. Alyssa? Divide the two numbers by 2. I think I know what you're saying is like 2 goes into 2 one time and 2 goes into 4 two times. You could also do 3 goes into 3 one time, 3 goes into 3 one time. You remember doing that? Oh, you don't remember doing that? Here's why that works, right? So if I do 2 over 3 times 3 over 4. Aubrey said we do numerator times numerator, denominator times denominator. The order does not matter that we multiply. It's the commutative property. The order of those do not matter. So I could say 3 times 2 over 3 times 4. Order doesn't matter. Anything over itself is 1, correct? So what I can do there is just cancel those out because it just turns into a 1. 2 over 4, that can be reduced to 1 over 2. That's what that means. So 1 times 1 is 1, 1 times 2 is 2. So the answer to that is 1/2. Same way here. All I did was I canceled 2 goes into 2 once, 2 goes into 4 2 times. 3 goes into 3 once, 3 goes into 3 once. Then multiply across. It sounds confusing at first, but once you see a few examples, it's really not that tough.
I'm looking if you just do like your second one there.
Like this one? Yeah.
Is it okay if you just did that, but then at the end, like you get 6 votes, and just make that?
Well, some you would, some you wouldn't. So let's look at the second example. Here I've got negative times a positive. So I've got a negative times a positive, so my answer is going to be negative. Once I know my answer is negative, then I don't really care about the negative sign anymore. And now I'm going to try to reduce. I can cancel this. 3 goes into 3 one time. 3 goes into 9 3 times evenly. Is there anything else that I can simplify? Is there anything else that I could simplify? I could look at the 1. 1 goes into 1 one time, 1 goes into 4 4 times, but it doesn't really gain meaning. It doesn't really simplify the problem. So this is all I can do right now. So negative times a positive is going to give me a negative. 1 times 1 is 1. 4 times 3 gives me 12. So my answer there is negative 1/12. So simplify and then multiply straight across. Go.
Why did you simplify it with the 3 and the 9?
Because if 3 goes into 9 3 times evenly, 3 times 3 is 9, right? So what that does is, if I had 3 over 9, that simplifies to 1/3. So what I did was 3 goes into 3 one time evenly. 3 goes into 9 3 times evenly. So what it did is it just simplified it, kind of reduced those numbers to make them friendlier when I multiplied them out. Now let's look at some mixed numbers. That's going to be our next section. So 1 1/3 times 2 1/2. There is one rule for multiplying mixed numbers. You have to convert them to improper fractions. Have to turn it into an improper fraction. So to turn this into an improper fraction, I multiply the whole number out front times my denominator. 1 times 3 is 3, plus 1 gives me 4. That's 4 over 3. Times, multiply my second fraction. 2 times 2 is 4, plus 1 is 5 over 2. You see anything there I can simplify? Once you turn them into improper fractions, then you multiply them just like you did up above. Sure, yeah. 2 goes into 2 one time evenly. 2 goes into 4 2 times evenly. Anything else? Nope, that's it. So now I'm going to do 2 times 5, numerator times numerator, gives us 10. 3 times 1 gives us 3. That's an improper fraction, so make it a mixed number. 3 goes into 10 3 times. 3 times 3 is 9, so there'll be 1 left over. So your answer is 3 1/3. Somebody in another class said, Mr. Thompson, that's the long way. Here's how I do it. They say 1 1/3 times 2 1/2. They say, here's what I do. I take this number times that number, that gives me 2. 1 times 1 gives me 1, and then 3 times 2 gives me 6. Is that going to give them the right answer? No. That is by far the most common mistake that people make. Do not do that. That will give you the wrong answer every single time. Do not do that. Improper fraction and then multiply across.
The improper fractions.
Uh-huh.
Like I did the numerators on this and the denominators on this, and then I got the 9 over 6, and then you take that and have it equate to
Yeah. Yeah, you can use the calculator. Yeah, you can use the calculator to check any of those. Yeah. The problem with relying on the calculator is once we start getting to the algebra section, the calculator is going to really let you down, and that's a big problem that a lot of people have. So I got another mixed number here. This time I've got a negative. I'm going to do it the same way. I got to change my fractions to improper fractions. 3 times 2 gives me 6, plus 1 gives me 7. That's 7 over 2. I'm going to multiply that. Now be very careful here because this negative applies to this whole fraction here. The whole fraction is negative. So when I'm looking for my improper fraction, I'm going to do 1 times 3 plus 2. And that'll be 5 over 3. It's the whole fraction that's negative, not just the 1. Now I'm going to do a positive times a negative. My answer is going to be negative. 7 times 5 gives me 35. 2 times 3 gives me 6. So that means I've got 6 goes into 35 5 times. 6 times 5 is 30. So I'm going to have 5 left over. My denominator stays the same. Now for the algebra. This is the part you've been waiting for. X squared over 4 times 2y over xy.
What does x and y mean?
They're variable.
They're variable. And the nice thing about the algebra is we solve this the exact same way we solve the stuff up top, except for now instead of dealing with numbers, it's just letters. No, we solve it the exact same way. Anything over itself is 1. So we can cancel that way. There are some tips that I'm going to give you. One is when you see these exponents, get rid of the exponent, because x squared means x times x. So I'm going to get rid of that, and I'm actually going to put another x on there. It's just easier to solve the problem that way. And now I'm going to cancel the same way I canceled before. What's something that's on the top and the bottom that I can cancel out?
The x's.
Sure. I've got an x on the top. X goes into x one time. X goes into that x one time. What's something else that's on the top and the bottom that I can cancel out? Caleb?
Y.
Sure, I got a y on the top that I can cancel and a y on the bottom that I can cancel. Anything else? Correct? Sure. 2 goes into 2 one time. 2 goes into 4 2 times. So now on the top I've got 1 times x times 1 times 1. So that leaves me with just an x on the top. On the bottom I've got 2 times 1 times 1, which is just 2. My answer is x over 2. My 2 kind of looks like a z, but it's a 2. What do you mean, up here? 1x? Sure. 1x and x are the same. It's 1x over 2. So it would be like 1/2 x. It's x divided by 2. Yeah. Let's look at another one here. A b to the third over 9 times b over a squared. Do the trick that I just suggested. All right, so let's look at this. I'm going to do the trick that I told you about. Get rid of that and make it into 3 variables. Get rid of that and make it into 2 variables. It's less confusing this way. Now, what can cancel? Give me something that'll cancel. Give me something else. Sam? Can't cancel on the top. Remember, it has to be over and under. Is there anything else that can cancel? There's nothing else that can cancel. So on the top, I've got b times b times b times b. So what's that going to be? B to the 4th power over 9 times 1 times a will give me 9a.